Hari Kanna.
So now it's time to see the applications of combinations in machine learning. So combinations are also a useful concept in machine learning. So particularly in the fields of feature selection, very very important feature selection, dimensionality reduction, and ensemble methods. So here are some of the applications of combinations in machine learning. Let's begin with the feature selection. In feature selection, combinations are used to generate subsets of features from a larger feature set. These subsets can be used to train a model that uses only the most relevant features from the given task, reducing the complexity of the model and improving its performance. So, if you take an example, so combinations can be used in feature selection to generate subsets of features from a larger feature set. For example, given a data set with 20 features, combinations can generate a subsets of 5 or 10 features that are most relevant to the given task. So these subsets can be used to train model that uses only the most important features, reducing the complexity of the model and improving its performance. Then we have a dimensionality reduction. Dimensionality reduction. In dimensionality reduction, combinations are used to generate a new features from a larger feature set. So these new features can capture more complex relationships between the original features, reducing the dimensionality of the data and improving the performance of the model. So dimensionality reduction. So the combinations can be used in dimensionality reduction to generate new features from a larger feature set. For example, given a data set with 20 features, combinations can generate new features that capture more complex relationship between the original features. So these new features can be used to reduce the dimensionality of the data and improve the performance of the model. Then we'll go for the ensemble methods. In ensemble methods, combinations are used to generate subsets of models from a larger pool of models. These subsets can be combined to create a more robust and accurate model that can handle wider range of the data and improve the overall performance of the model. So if you take up ensemble method, so combinations can be used in ensemble methods to generate subsets of models from a larger pool of models. For example, a given pool of 10 models, combinations can generate subsets of 3 or 5 models that are combined to create a more robust and accurate model. So these subsets can be selected based on the various criteria such as diversity, accuracy, and computational complexity. Then the last one, but not the least, that's hyperparameter tuning. Hyperparameter tuning, very very important. In hyperparameter tuning, combinations are used to generate different sets of hyperparameters for a given model. So these hyperparameter combinations can be used to train multiple versions of the model with different parameter settings, allowing for the selection of the best hyperparameters for the given task. So if you take up an example, combinations can be used in hyperparameter tuning to generate different sets of hyperparameters for a given model. For example, given a model with 5 hyperparameters, combinations can generate different sets of values for each hyperparameter. These hyperparameter combinations can be used to train multiple versions of the model with different parameter settings, allowing for the selection of the best hyperparameters for the given task. So in each of these examples, combinations are used to generate subsets of combinations of elements in a given set, allowing for the optimization and improvement of the machine learning models. The main agenda of these combinations with respect to the machine learning is improving or allowing the optimization and improvement of the machine learning model. So that is the reason combinations, understanding the combinations is very, very important for a data scientist. Very, very important. So overall, combinations are a powerful tool in machine learning that can be used to generate subsets or combinations of elements in a given set, making them a valuable tool for optimizing and improving machine learning models.